right, today we're looking at the first half of chapter 4, the first couple sections of chapter 4, which is mainly all about exponents, what an exponent is, what it tells you to do, and then looking at some exponent rules to finish us off. So first we have exponential notation, which you've probably seen before. You have some sort of a base number, and it's a tiny raised number next to it is the exponent. And so in this case, we might say like a to the nth power. For a frame of reference, usually we'd see more something like this, right? Like 2 to the third power, things like that. So you got the base, you've got the exponent. All right. It says an exponent of 2 or greater tells how many times the base is used as a factor. So that's kind of a technical way of saying that the exponent is basically a counting number. It counts how many of the base number are being multiplied together. So in this case, a to the fourth means we have 4 a's that we're multiplying together, right? The 4 just is telling you how many, it's a count. So there's going to be 4 a's, right? 4 of that large base number that you're going to multiply together. Okay, so that's what that basically means. All right, so anytime, other examples of this, so like 5 squared actually is 5 times 5, right? It's telling you have 2 5s that you're multiplying together. Not 5 times 2. The answer to this wouldn't be 10. In this case, 5 squared would equal 25 because 5 times 5 equals 25, so on and so forth. 2 to the third power doesn't mean 2 times 3. It means I have 3 2's that I'm multiplying together. So it expands out to 2 times 2 times 2, which means 2 to the third power would have to be 8 because 2 times 2 is 4, 4 times 2 is 8. All right. A couple of special cases, just because they can get confusing for someone to see, is if you have any number raised to the power of 1, it's just that number, right? 5 to the 1 equals 5, 6 to the 1 equals 6, 7 to the 1 equals 7, etc. The one that kind of freaks people out is 8 to the 0, meaning any number raised to the power of 0 equals 1, unless, of course, the number that you're raising is 0. 0 to the 0 is still 0. But any other number raised to the power of 0 equals 1. So in this case, 5 to the 0 equals 1, right? 4 to the 0 equals 1. 356 to the 0 power equals 1. No matter what the number is, if you raise it to the power of 0, it's going to be 1. Okay, and there's a reason for that, and I can explain it later because it makes more sense once we look at a couple of the exponent rules. Okay, so here on the next slide, it's just some practice, right? Practice making sure we know what these things mean. When you see 6 to the third, it says write as a product. Product meaning a multiplication problem, right? The result of a multiplication problem. So 6 to the third translates to 6 times 6 times 6. Easy enough. 2 to the fifth means I have 5 2's that I'm multiplying together. So I'm going to do 2 times 2 times 2 times 2 times 2. Okay? We could figure that out. Right now they just want us to write it as a product, just to make sure we know what 2 to the fifth means before we even try to figure out what the value of that actually is. 3 to the 0, don't be tricked. Don't say 0. We just went over this. It's 1. Okay? The ones I want to really bring to your attention are 4 and 5 and 6 and 7, because 4 and 5 look really similar, but they're actually two different things. The thing about exponents is that the exponent goes with what is directly in front of it. It goes with the factor that's directly in front of it. There's actually two things going on here, right? There's an exponent and there's multiplication. This says 3 times t to the second power, right? And remember, when we're looking at order of operations, you always want to do exponents before you do any multiplication and division. So what this is actually saying is I want to raise t to the second power and then multiply by 3. So what this would look like as a product would be 3 times t, right? Because t squared means I'm raising t, I have 2 t's I'm multiplying together, and then that whole thing's being multiplied by 3, right? As opposed to this situation where they have 3t in parentheses, meaning they're grouping it together. They want it to stay together. And then outside the parentheses, they're raising this entire thing to the power of 2. So in this case, it would look like this. Both the 3 and the t are getting multiplied twice. All right. In this one, it's not this whole 3t that's being squared. It's just the t. In this case, the whole 3t is being squared because they're purposely grouping those two factors together first. Okay, these two would end up giving you two different things. Because see how here, let's just say t equal 2, for example. I'd have 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. All right, here I have two 3's that are being multiplied together. Right, I have 3 times t times 3 times t. Well, 3 times 3 is 9, right? And then you would multiply these. You'd have two 2's. You'd also have to multiply in there also, right? 9 times 2, 18. 18 times 2, 36. So you'd get very different answers. So these are two completely different things, even though they look like they're very similar as far as how they're written. Okay, so looking at 6 and 7, all right, negative x to the 4th power, right? They're putting a parenthesis around the negative x. So that means they want me to raise this entire thing to the power of 4. So that would be negative x times negative x times negative x times negative x. I'm using parentheses to separate it this time just because that negative, so that the negative and multiplication signs don't look confusing. All right, so that's what that would represent. This one, although it looks very similar, is not, because remember the exponent only goes with what's directly in front of it. You know how when we have 2x and 3x and 4x, and say when they have just x, and I say, well, what number is really being multiplied by x, even though they don't write it? Hopefully you're thinking 1, right? X is the same thing as 1x, just like if these were negative, right? Negative 1 times x, they'd still just write it like this. They don't put the 1 there. So really what this actually is happening is negative 1 times x to the 4th. That's what that kind of looks like, which is the same situation as this one up here, number 4. I have multiplication, I have exponents. So really what's happening is what's being raised to the 4th power is only the x. And then after you do that, right, exponents first before multiplication, after you raise the x to the 4th, then you're multiplying it by negative 1. So what that would look like is negative 1 times x times x times x times x. 4x is being multiplied together, multiplied by negative 1. Okay? Once again, it would give you two different answers, right? Because even though in this example and this example, we end up multiplying 4x's together, in this one we have 1, 2, 3, 4 negatives. In this one we just have 1. So we would end up with a positive answer here and a negative answer here. So it's important to distinguish the difference between this and this and this and this, right? When you have a couple of things in front of an exponent, you want to make sure you know what's getting raised to the exponent. It's not everything in front of it. It's just the first thing in front of it, okay? So over here, they have us do it backwards, write in exponential form. What I would do is pause this for a second, try to do it on your own, and then see if we match, okay? Pause. I'm going to keep going. So we got 3 3's being multiplied, so that's 3 to the 3rd, right? Here, I've got 2 x's being multiplied together, right? X times x, that's the same thing as x squared, and then they're multiplied by 4. So that's 4x squared, okay? Notice it is not 4x squared. That would be different. That would look like 4x times 4x times 4x. Oh, no, wait, sorry. That would look like 4x times 4x, not 4 times x, okay? So it's not that. 2a times 2a times 2a times 2a. In each case, I have an entire 2a all being multiplied by each other 4 times. So this is a case where I would have to put those parentheses around 2a to show me that I'm multiplying 4 2's together and 4 a's together. If I just write it like this, then what this means is I have 4 a's that I'm multiplying together, and then the whole thing is being multiplied by 2. So this is completely different than this. Right? Here you got 2, 4, 6, 8. So you're going to end up with 8 times whatever all those a's are. In this case, it's just 2 times whatever all those a's are. 2 different answers. Okay? We didn't write that. And then for number 11, only the y is being raised to the 3, and then the whole thing's being multiplied by negative 1. So it would look like that. Okay? If you want to do this because it makes you feel more comfortable, so that you know you're writing it so that only the y is being raised to the power of 3, you're welcome to do that. You don't have to. the way we had it was just fine, or even like this, because it's the same as number 7 down here. Okay?
Move